Okay, so just a quick reminder, the test is next Wednesday. I should have the practice test up there by this Wednesday, so you can practice it. We will then go over and review the test next Monday. Same thing I did last time. And I'll take the test on Wednesday. So same concept as last time. I'll go over all the questions just like the review. It might be a few extra questions, just because I think the other one was a little short, but these are a little more complicated, so it might end up balancing out to be about the same. So it shouldn't be any more than 15 total.
So the test is the 30th.
Yep. So chapter 8's the last one we're going to go through. So on last week, we looked at a discrete distribution. And discrete distributions, each bar had the specific thing. We still had the expected value, which was our mean that we found. Sometimes it was in the middle, sometimes it wasn't, depending on where it fell. But the discrete ones, they had bars that we could easily see. When we're moving into a continuous distribution, those bars get really, really small because every single one of those values would occur. And by getting them really small, what we basically end up creating is almost exactly like the bell curve, where your expected value, your mean, is going to be right in the middle. And you're going to have stuff on either side of it. Concept is probability is going to go to 0, but those cases on the extremes can still happen. They're just going to be extremely unlikely to happen. Okay, so the first thing we're going to look at today is we're going to really look at how the bell curve works, how we can find those probabilities and that information, and then we'll start looking at some problems on how we can take that and turn it into a binomial experiment like we did with the discrete probabilities. So first thing, let's quickly review what we talked about back in chapter 4, which was the empirical rule. So if I was to cut the curve directly in half, how much is on each side? 50%, right? It's symmetrical, 50% on each side. The empirical rule told me that each standard deviation, for one standard deviation around the mean, I have 68% of my information. 2 standard deviations around the mean, I have 95, and 3 standard deviations was 99.7. Does that ring bells at some point? Okay. This works really, really well when we're talking about exactly 1, 2, 3 or standard deviations. However, if I get down to what if I wanted 1.2 standard deviations or those type of things, that makes it a little more complicated to figure out, and we need to do some calculations around it because the empirical rule no longer actually works. First thing we can do, though, is we can actually split it up even further than that. So that 68% means I have 34% on this side, 34% on this side. So you can break down each individual's piece into those values. So that'll help you somewhat. So if I only want one side, I can easily find that. So let's say I wanted to figure out the values of everything. Let's change this to orange. All the values up to here. So we know that this side over here is what? That's 50%. And this just told me that this piece right here is 34%, right? So what would be the total? That'd be 84%. Okay, so we can easily work with those type of things to add things up. But again, that doesn't necessarily help me if I want 1.2. So we have something known as z-score. Our z-score is looking at needs two pieces of information and then what we're looking for. So my z-score tells me how far away from the mean the value that I'm looking at is in standard deviations. So to do that, we take our value that we're looking for, subtract the mean, and divide by our standard deviation. Okay, it's actually a very simple formula, and believe it or not, by the end of class, you'll will completely understand this. This is not complicated at all. But let's look at the mean and standard deviation just quickly to remind us what those actually mean. Standard deviation tells me how far things are spread. The larger the standard deviation, the more spread the information is. So a standard deviation of 1 is a lot tighter than a standard deviation of 2. My mean just tells me where the middle is. It doesn't change how much it's spread. It's just telling me how the middle piece is. So the mean of 0 is there. 3 and 7 would be shifting it over to the right. Okay, but the lines and everything else doesn't actually change in that respect. All right, so let's look at an actual real life situation. So the average man in the United States is 5'9", which is 69 inches, with a standard deviation of 3 inches. Okay, so the mean right down the middle, that's my 69, correct? What would be one standard deviation away from the mean? 72 that way, or 66 that way. Okay. And then 2 standard deviations would be 75 or 63. Okay. So I saw one of those little images and stuff from memes on Facebook the other day. And it was this woman's dating profile. And the very first line of it says, male must be over 6 feet tall. Okay. Fine. You have your choices. You have your options. Very good. So what percentage of the people what percentage of men did she automatically eliminate from possibilities? So that's 1 standard deviation above, right? And we just determined in this, or actually back here, 1 standard deviation above is 84%, right? So she's just eliminated 84% of all the men in the United States from possibilities. Okay, so now she's down to 16% that she can look at, and then there's a whole list of other things underneath that made it even smaller. But that's thinking about literally just the standard deviation and the averages and stuff like that. That's what that means. Okay, that actually easily can be done. Okay, because we have enough to actually show the standard curve for that. All right, but what if I wanted to find 74 inches tall? Now that becomes a little more complicated, right? So to do 74 inches, I need to find my z-score. So my z-score was x minus this mean over the standard deviation. So in this case, x was 74 inches. My mean is 69 inches. And my standard deviation was 3 inches. So z is 74 minus 69 divided by 3, which is 5/3 or 1.67. All right, so now the question is how do we find that? So when we're looking at this,
Can you go back to that other screen?
Yep. So it means that 74 is 1.67 standard deviations away from the mean. Okay. So I can't just go, okay, well, it's 2/3 of whatever the percentage is in that box because it curves. It's not a linear equation. So we need to do some calculations, or we're going to use a table. So who wants to pass these out for me? Okay. All right. So what he's passing out now is known as a z-table. Oh, no. This is easy.
No, it's not.
Oh, no, it really is. It looks complicated. It's not.
A lot of numbers on it.
Yes. Check. All right. So if we look, the z-table has negatives on one side, positives on the other side. Okay? If you look at all the numbers in the middle on the negative side, What's the biggest number in the middle?
0.4840. No. What?
0.5. Thank you. All right. So now think about it. The negatives is one side of the graph. So if we go back to my original wonderful little bell curve here, the negatives are on this side of the graph. And we said half of it is 50%, right? 0.5 is 50%. If you look at the positive side, it starts off at 50% and goes to 0.9999999. Like it just gets basically 1, right? Okay. On the sheet, there's two sides, positives and negatives. These are so the z-scores are on the outside, the percents are in the middle. Here, let me bring one up on the screen. Negatives. Okay, so on the outside is your z-scores. In here is your percents. So if we go all the way down, the biggest number right there, it's 0, is 50% or 0.5. Find that on your sheet.
What does that tell them?
That tells me that a z-score of 0 is 50%. Now, if you think about what we just did to find my z-score, how would I get a 0? How would this come out to be 0? Right. Your mean has to be the exact number you're looking for, right? The only way for this to be 0 is that top has to be 0, correct? Which means these numbers have to be the same. So if you're looking at your mean, that's 0. That's 0 standard deviations away from the mean. Okay? All right. So we're there. Now, on the chart, go to the positive side and find me 1 standard deviation. What's the percent next to it? 0.8413, right? What did we say was the percent for 1 standard deviation away from the mean? 84%. Okay? So this is telling me the percent.
Oh, because you would multiply that by 100. to get
Yeah,
84.
yeah.
Got it.
It's telling me the percent from the left all the way over to whatever that number is. Yes, this is literally for a bell curve. What we're going to find through the rest of this class is that almost everything falls into a bell curve. Okay, this sheet is going to become your friend for a lot of lessons coming up. Okay, I will give it to you for your tests, but don't lose it because you're going to need it a lot. All right. What would 2 standard deviations be? I would add another 13.6 to that 84.1, right?
98.
So 98.7 basically.
Well, 97.
Yeah. So if you look at 2 standard deviations, you get 0.9772. And if we added the 50 plus the 34.1 plus the 13.6, it's basically 0.999772, right? It's right there. Yes.
Look at the left side of standard deviations.
So the z-score tells you how many standard deviations you are away from the mean. So those are your second part of your decimal point. We're going to get to that in a second. So notice we're only looking at that first column where the second row is 0. Okay. We're going to get there in 1 second. Nope, not difficult. Don't stress out yet. You good. You got the 99.9772. You're good there. All right. I wanted 1.67, right? Okay. So now we need to work over. So we're going to go to my z, and we're going to go down to 1.6. And then we're going to go over to the second number, that's the 7. So I get 0.95254 or 0.9. Oh, sorry, on yours it's not. I got one extra.
Yeah.
0.9525. Right? So what that means is that from here all the way over to that 74, that is 0.9525 or 95.25%. Okay? Was it easy to find the number?
That was fine, yeah.
Okay?
I get
I know, lots of numbers, not complicated to find stuff. Okay? We good? Great, you're done today. No, I'm just kidding.
that. That would be way over on the other side, right?
Correct. So, well, it's between 1 and 2. 1.67 is between 1 and 2.
Negative?
No. Oh, hold on. Bad screen. 1.67 is right there. It's between 1 and 2.
Right, but you have your arrow.
That whole shaded area is 95.25. That's that whole area. Yeah, no, that's that whole shaded area.
Got it.
All right. So the key piece to understand is that Z table is telling you everything from the left all the way over to that number, whatever it is. All right. Now we're going to take a step back and we're going to work with just the Z scores. All right. We're not going to find the Z scores. We're just going to use the Z score to find information. Okay. And then we'll go back and do some other problems that actually have us find the Z score and put it all together. But I wanted to give you an idea of like a real life example of where it's used. So this makes sense. All right. So it says compute the probability when it says standard normal random variable. That's Z score. That's all it's asking for. So they're giving you your Z score as 1.27. Okay. So what I will suggest, and on Wednesday's class, I will bring you some sticky notes with like bell curves on them. I don't have a ton, so I'll pass out a few to everybody. But if you want to go on Amazon, you can literally buy a package of them. I think they're like $5, and you get a whole bunch of sticky notes with these bell curves on it. You're going to use a bunch of them. Sketching it is going to be the key to figuring this part out. Okay, trying to visualize where you're doing it in your head is not going to work for everybody. Some people are going to be great at it. Most of you are going to make mistakes. So drawing a quick sketch and doing it like I'm going to show you here is going to be helpful. So 1.27 is going to be somewhere between 1 and 2, right? So that's there. And they want less than that. So they're looking for all of this. They want all that percent right there. Okay? That's what I'm talking about sketching. Is just putting your information there and shading what you're looking for. This one's simple. They become a little more complicated. All right. Yes. What do you mean? We can go to 2 decimal places. The sheet will always go to 2 decimal places for your Z scores. So if you have 3, then yes, you'd round. But in this case, all the numbers I'm going to give you are 2 decimal places. So we want to find 1.27 on the Z table. So am I on my positive side or negative side? Positive. So I'm going to go down to 1.2 and then over to 7. So on your sheets,
89.8.
so 1.27 is 0.8980. So this is 0.8980. That's the probability.
So would you turn that into a percent?
It depends on what Hawks asks you. So I believe, if I remember right, on Hawks, they will typically put a percent sign after the answer box
Okay.
if they want it as a percent. If they do not, leave it as a decimal. Leave it just like that. So the answer to this question is 0.8980. Okay? That makes sense? We're good so far? Take your picture.
I know, I got.
Oh, no. Somebody behind you was. As I said, take your picture. No, you're fine. All right. So now the next one. They want a number between 0 and 1.27. So again, 1.27 is right here, right? Again, it doesn't have to be exact, just close. And 0 is here. They want the information between the two, right? So they want that spot. So, how are we going to do this?
1.27. What do we say? 0.890.
Yeah.
Subtract that by 0.5.
So we know that this whole thing, right, was 0.8980, right? And I don't want that, right? And that half is 50%. So we do the 0.8980 minus 0.5. And we get 0.3980. And that's my answer. Okay, so I'm just cutting off that 50% that I didn't want. Okay,
Hold on a second.
you're fine.
Is that correct?
Yeah.
So if it wasn't asking for like a simple 50%, would you have to find?
We'll do one of those.
Oh, okay.
We're going to do it. But good question.
But I already know it's gonna be one.
Oh, yeah, it will be. You are right.
Okay.
All right. Try this one. Don't scream out the answers. Just try it. Come up with what you think the answer is. And then we'll do it. All right. Where am I shading? Shading over there. Because I'm looking greater than, right? Okay. What was the answer to the 1.27 that we found? Right? But that's from the left, correct? So how do I find the other side? I find the complement. Okay? Because that's the exact opposite, right? So if I'm finding the complement, I just subtract it from 1. So 1 minus 0.8980 is 0.1020. And that's about it.
That one confuses.
The whole side, the whole thing is 1, right? If I look at everything, it's 1. The total probability is going to be 1. Okay. So if I know one side is 89,980, and I want the other side, I just subtract it from 1, because that's the complement. Minus 0.8980. So that's the complement. All right. So just remember that halves are 50, so the entire thing would be 1. So that's why I'm taking, and I want the opposite. This is this side, because it's always from the left over. And I want the right side, so I just subtract from 1. All right, try this one. Which section am I shading? So this section, this section. So I'm shading here, right? So we want that section. Okay. So if I look up negative 1.08, what do I get?
0.1401.
So 0.1401, right? And that is what part? That's this, right? That's all that. That's the 0.1401. Okay, I don't want that part.
That number from 0.5.
Okay. So this section over here I know is 50%, right? This whole side. So this side here, 50%. So if I take away that 0.1401 from the 50,
We're gonna be reading this from -3 to -1.
0.08. Yes,
It's not separate.
correct. So the number that you get on here is always from the left to that number. So that when you looked up got the 14.01, it is from the left to negative 1.08. Okay. Not the other direction or anything else. It's literally that piece there. So I know that that part right there is the 14.01, but I want this piece in here. I know that that whole side is 0.5. So I subtract. And I get 0.3599. So that is that part right there.
Why is it a negative? 1401.
It's you're subtracting 14.01, not negative 14.01. That's why I said the hardest part of this is not finding the numbers. The hardest part of this is figuring out what piece you're looking for and how to find it. So because think about it like this big pizza or big pie. You're looking at the pieces. We are looking at half of it right now. Okay. And I'm always eating from the left side in. So I ate 14.01. How much of the left of that half? Right, is the 0.3599. Okay. So you always start at the left and move your way in. Think about it just like you read. You read from the left over. That's how that number is going to come up. Okay. What's the probability between 1 and 2? Well, yes, we had that little chart, but how can we use this to find it? Because yes, that chart's nice, but it's not exact. So we're looking between these two, right? So we're looking for this part right there. So what's 1? Oh, you subtracted them already? What's the 1? What's when you look at your sheet, when you get the z-score of 1, what do you get? 0.8413. Okay, and what's the z-score for 2? Or what's the probability for 2?
I'll just subtract those two and do that.
Why?
Because that's the difference between the two.
Okay, so I just subtract it.
Because that's the only area that we're measuring.
Good. Good. No, that
Right?
so you're correct. You're supposed to subtract them. You have the right answer. I wanted to make sure you understood the rationale of why you're subtracting those two numbers to get the answer. Okay, which is fine. You got that. This is the 0.8413. That is the 0.9772. When you're looking for the difference, you're going to subtract the piece. Remember, it's always starting from the left and going over to it. So if we're looking between two pieces, we're going to subtract the biggest one minus the smallest one. That's how we find the difference between them. Perfect. You're great. Good. Awesome. Next one.
Yeah, no thanks. No.
We already did this.
Says here.
You're right. Because we did. What did they not give me in this?
Correct numbers.
What do you mean by the correct numbers?
Ah,
What have we been using? Right. We don't have the z-score, right? They gave us information, but they didn't give me the z-scores. So do we have a way to find the z-scores? Yeah. So let's find the z-scores. So my mean is 10, is 20,
20.
and my values I'm looking for is 10 and 40, right? Okay, so if x is 10, my z is, it's 10 minus 10 divided by 20, right? These are the values I'm looking for. I'm looking between 10 and 40. So x is 10, my z is 0, right? And then if x is 40,
Wait, what?
What are you doing?
yes, you do it for both.
Where are you getting 10 minus 10?
X minus your mean divided by your standard deviation. The value you're looking for is 10.
Okay, yeah.
So it's 10 minus your mean. The formula was x minus the mean divided by standard deviation. See, remember this right here?
Yeah.
So if x is 10, 10 minus 10 divided by 20.
Divided by 20. Okay.
So in this case, the x was 10,
20.
is 0. Is 0. Now the other x was 40. So I do the exact same thing. 40 minus 10 divided by 20. 20. Yes.
What is that? for Z-score, is it typically gonna give us a lie between 10 and 40?
No, not always.
Could it be like, find this number?
Yeah, it could say we find up to, I'm going to do a couple of those. So yeah. So we're looking between those two numbers, right? Okay. So what was 0? That's the 50, right? And what's 1.5?
0.9332.
And what are we going to do those two numbers? That's my answer. That right there. That's 0.4332. Told you we did it.
I remembered, but I just had a hard time.
So again, everything we like, I honestly believe that you guys could look at the Z table and find me, and I could tell you the Z score. You can find me the answer. Like that's not the hard part. The hard part is figuring out where you're looking for and getting that. In most situations, you're not going to be given the Z score. You're going to have to find the Z score like we did in this problem. Okay, but the Z score formula is really simple to do. It's one subtraction and a quick division, and you're done. And then it's right back to what we did a minute ago, just finding those numbers and figuring out what you're doing with them. Are you going to add them? You're going to subtract them? You're going to what? And most of the times, we're going to subtract. All right. Or we're just going to use the number they gave us. Okay. You're typically never going to add. All right. Do this one. Huh? So my Z is 1, and I want greater than it. This is greater than 30. So 30 minus 10 is 20. 20 divided by 20 is 1. And since it says greater, I want the greater side. So which number am I getting? 8413. I got distracted from what? 1, because I want the complement of it.
So where does the 20 come in?
Standard deviation of 20.
Where is it on your?
It's on the bottom. My standard deviation.
So is the Z score, is that where you're finding to go on the
Yes.
bell curve?
Yeah, that's going to tell me where they're going in the bell curve.
Okay. That's why I asked you if the 30 was.
Oh, gotcha. Yeah, no. So in this, so the key is, so the bell curve, I could have the 30s and all those other numbers down the bottom, and the mean would be at 10, and it would spread.
Yeah.
The reason why we use the standard or the normalized random variables, it's easy to go all the way back to 0 because now we can use the tables. So by doing the z-score and everything else, we basically move it directly back to the table and we can easily find it and compare everything. So that's why you normally will not see me draw a curve with the numbers on the bottom that actually match up with what it is, because then we have nothing to go back to use. So everything goes back to that curve. So, yes.
Where's the 1, 5, 8, 7?
So remember, this is from the left. So this is 0.8413. I don't want that side. I want the opposite. I want the complement. So the complement is 1 minus that. Because the whole thing is 1. I don't want that side. I want the other side.
Right.
Would it be slightly different if you did? Well,
What?
I did 3 minus 1, but that's not all.
So, okay. So if you did the 3 minus the 1, where's 3? Okay, 0.9987. Is it 1? No. Because we only typically go out to 3 standard deviations because after that point, it's basically nothing. It's very, very rare that things are going to happen, but it keeps going. So there are values past 3. And actually, this chart goes up to 3.49, which you're now at 0.9998. Okay, so you're even closer. So that's why we just make the assumption that because I want the complement, I'm subtracting from the 1. So this way I'm not ending anywhere. It's literally going all the way out to infinity. Okay.
So the 10 is the variable.
The 10 is my mean. So it's the mean of 10.
Mean is 10.
My deviation is 20.
Deviation is 20.
And the value we're looking for is 30. Okay. All right.
So it's the value minus the mean.
Yes. Yes.
Divided by the deviation.
All right. Do this one.
Oh my God.
What do you need? You only need 3 well, you need 2 numbers first.
Right.
Mean, standard deviation. And then you need to know what your x is. That's it.
There's 4 numbers up there.
Well, yes, but figure out one of them doesn't mean anything. Well, actually, there's 5 numbers technically. The problem.
Right.
One of those 5 you don't need at all.
Well, I know the first one doesn't.
Right. So we've done one when we had 2 z's. The very first problem we did after we started looking for z-scores, we had 2 z's we had to find. All right, it's going to blink for a second because my screen just froze.
Oh,
So that should have been your first step. So when you're looking at these problems, most of them are going to be word problems. Pull out your mean, pull out your standard deviation.
So how do we find the problem?
Huh?
How do we find the problem?
How would I find the probability now? Okay, so we've got our z's, right? So the next step is do a little sketch to figure out what we're looking for. So negative 1.43 there, so negative there. So I got negative 1.43 and negative 0.89. And we're looking between those two, right? So now, look at the negative side. So negative 1.43 is 0.0764. And then negative 8.9 is 0.1867. That make sense? Okay, and now what are we going to do with those two numbers to find between them? Just going to subtract them. Somebody want to do that quickly because I can't do that one in my head. 1103. So that's the probability between them. So there's an 11% chance the next purchase will be between $100 and $150. Yes.
Like the silly question, but like there, obviously we've subtracted every time. Is there really time?
No, you'll never add them. The only time you would ever add is if, like in the very beginning when we were looking at, okay, I found one side, I added the 50% to the other one. That's the only time. But honestly, you're not going to do that. Now that you have the z-scores, you're not going to do that piece. You'll only subtract. And remember, your answer's got to be between 0 and 1, right? No matter what, the answer's got to be between those two values. So if you get a negative answer, you probably screwed something up. If you get something bigger than 1, you probably screwed something up. So go back and look and figure out where you made the little mistakes. All right, now I'm going to dig
hold on.
way back in your memory. You're fine. Anybody remember how tall the doors are I told you? How many inches tall is the door?
All right, so I got 1.43 and 0.89.
Yeah. Now look at your chart. That's where the other two numbers came from. Nobody?
82.
On either side of it, it's 80. Standard height of a door in the United States is 80 inches. Okay? So at the very beginning of class, I gave you some very specific information about the heights of males. Okay? How many males are going to hit their head on the door? What percentage of males will hit their head on the door?
Where's your? I'm so confused. Where are you getting these numbers?
Start. Look at negative 1.43.
It's negative 1.43.
Yeah, 100 minus 234 is a negative number. There's a negative side too.
Wait,
Flip the paper on.
hold on. 230.
X is 100. 234 is my mean
Why would it be 234 minus 100?
because it's the value you're looking for minus the mean. It's not the mean minus the number. Your z-scores can be negative if they're below the mean. Yes.
So they're both negative.
Yes. You good?
No. Sorry.
It's fine. They're working on something else. It's fine.
The standard for height.
It was 3.
I didn't get that part.
So
I didn't tell you. I told you at the beginning of class. I didn't tell you just now.
do you add those two together?
Subtract.
Mm.
Because again, this is 1 and that's the other one. I want the gap between it. So this is 0.0764 and that's 0.1867. To find the space between it, you subtract.
So this would the total 0.1103.
Yes.
Okay.
Nothing's impossible. You start to just go that high.
Wait.
But this goes to show you how rare it's going to be.
Okay, is it up?
And is it on the paper?
I don't know what's your z-score. It's not on the paper.
What are we doing now?
You're fine. You got your problem, right? You understand how to do that problem?
This one?
Yes.
Yeah.
Okay, good. Okay. So the question that I posed to the rest of the class was, what percentage of men are going to hit their head in the door at a standard height of 80 inches? You got your z-score as 3.667, right? Your z-score does not show up on your table. However, z-scores can go higher than that. Your table just doesn't go higher than that. So if you do on mine, if we go to 3.67, that's 5, 6, 7, 0.99988. So if we subtract that from 1, because I want half people to go bigger than that, right? 0.00012. So basically 1 out of every 10,000 men will hit their head in the door. Okay? So that's why our door heights are 80 inches. The chances of a person hitting their head in the door isn't going to happen very often. It's very rare. However, to make them taller costs more money. If I made them shorter, I would save money. However, more people would hit their heads. So they standardized it on 80 inches. Okay. Now, before anybody reports me as being sexist or anything else, why didn't I consider females?
Females aren't usually that tall.
They're naturally shorter. So at that point, it'd be even less for that. So the percent doesn't really actually change very much. That's why we don't look at the male side. Okay. So you can start to see how the concept of z-scores and that probability of things happening can impact your parameters that you actually use to build things. Okay. So that can make a big difference in that respect. The other situation that came up, and we'll actually do the calculations on this later in the semester, but it's actually kind of interesting. There was a ferry boat crash in New York. This was a long time ago. If you've ever gotten on a boat, actually, if you've ever gotten in an elevator, what do they say? What do they have in the elevator?
Wait.
A weight limit, right? Okay. And they typically have a person limit too on it. So if you look at the person limit and the weight limit, if you divide that, that actually comes out to be about the average weight of a person in the United States. So, well,
But
what
it really isn't.
it's not. It's a little lower. It's a little higher now. We've gotten fatter over time. So what happened on this ferry boat was they booked a tour for this company. Well, this company was a beer company, and the vast majority of their executives were overweight men. So they said, okay, our boat can hold 30 people. They had 30 men go on this boat. They were all a lot heavier than the expected weight limit,
Boat
and the
sank.
boat sank.
I remember that.
Okay. So the problem is that they were on the upper end of that spectrum. So what changed was, instead of looking at in terms of the number of people, they started looking at in terms of weight. And that's how they changed it. That's why in the newer elevators, you won't see the number of people anymore. You will just see a weight. So
I do remember
Yeah.
that story.
yeah, it was crazy. It was like,
It was kind of comical, but not. But it was, yeah.
yeah, nobody died, but
Yeah.
that's what ended up happening. So you can start to see how the concepts that we're talking about have real life implications, because everything that we do, we need to have some standard that we're looking at. And they use this for that standard. Okay. And that's how it impacts things. So, all right. That's it.
You don't have another example here?
Oh, there's a ton you're going to do. Just the key piece to it is drawing the sketch and filling it out. And you'll be fine.
I will bring this back.
I'll have